Hello everyone, welcome to TEQIP GATE an initiative by the TEQIP Faculties. I am Nihit. I have completed my MTech from IIT Gwalior in Digital Communication in 2014. I have qualified GATE exam 6 times. Present, I am working as an assistant professor at IISc IITs, Madhya Pradesh. I have more than 4 years teaching experience. So this is the 22nd lecture series of random variable and random process. Okay, this question was asked in GATE ECE 2010. XT is the stationary random process with power spectral density. That is, ये आपको दे रखी है XT random process की power spectral density for R value of F. The process is passed through a system shown below. तो ये system आपको पूरा इससे pass हो रहा है. Then this is the power spectral density of the process YT. Then which of the following statement is correct? तो आपको correct statement बताना है. So here power spectral density YT is given 0 for all value F. Here it is 0 for mod F given 1 kilohertz. Here it is 0 for n F naught, where F naught is 2 kilohertz. It is 0 for F to n plus 1 if F naught is 1 kilohertz. So let's say which observation is correct out of these 4. We have done such type of question in last class. So here you can see, let's say we have to find Sy of F, that is equal to mod H of F whole square S X of F. Okay, it is called the power spectral density of random process YT. It is equal to mod H of F square. It means the frequency domain, the impulse response, the square of the impulse response of the system into multiply the power spectral density of input random process, that is XT. So to find H of F, first we have apply here del T. If we apply input del T, that's why it's become YT equal to small h t. Okay, here del T and here del T. Here del T. So here there is a delay introduced. So let's say T equal to 0.5 millisecond. So that's why it's become del T minus capital T. Okay, del T minus capital T. So this, and after that after adding to both signals we have to integrate it. So differentiate it. So this become d by dt of bracket del T plus del T minus capital T. Okay. Now let's say if we apply this signal here del T unit impulse, then this by T become H of T. We know very well the del T is Fourier transform. This Fourier transform it is equal to 1. Okay, so it's Fourier transform equal to 1. So it is equal to 1. Here it is delay. It means del T minus capital T. So its Fourier transform is equal to e to the power minus j 2 pi capital T. So here we will receive e to the power minus j 2 pi f t dot 1. Okay, the Fourier transform of del d by dt it is equal to j 2 pi f. So after that h of f, that is equal to, so first we have to add both signal, that's why it's become 1 plus e to the power minus j 2 pi f t, then bracket. After that here the d by dt, it means we have to multiply j 2 pi f. Okay, now take now open this e to the power minus jx, it's become h of f, that is equal to, so now it is j 2 pi f bracket, it's become 1 plus cos bracket 2 pi ft minus j sin 2 pi ft bracket 1. Okay, it's equal to j 2 pi. Now I am going to take the modulus, no need to do this. So mod h of that is equal to, so this modulus become 2 pi f bracket b. Now this is a minus jb, so it's become root over a plus, it's become root over a square plus b square, so it's become cos 2 pi f t whole square plus sin square 2 pi f t. Okay, now open this sequence, so it's become 2 pi f, then it's become 1 plus cos square 2 pi ft plus 2 cos 2 pi fct plus, okay, so this square term and this square term and this plus 1, it's become 2 times of, so I'm using the some things here. What h of f, that is equal to 2 pi f bracket, so it's become root over 2 plus 2 cos 2 pi f t. Okay, where t is equal to 2.5 millisecond. Okay, then h of f whole square, that is equal to, that is this 2 and this 2 will come out from this square, and after whole square it become 2, and this 2 whole square become 4, this become 8, this become 8 pi square f square, and it is become 1 plus cos, and is in 2 pi into f into, where t is equal to 0.5 millisecond, so I'm writing is 0.2 into s square minus 3. Now h f, that is equal to 8 pi square f square, it's become bracket 1 plus cos bracket 2 pi f t, then bracket 1. Okay, where t is equal to 0.5 millisecond. Okay, now it is h of f square, then s y of f, that is equal to h of f square into s x of f, so it's become 8 pi square f square, then bracket 1 plus cos bracket 2 pi f t, then bracket. Okay, let's multiply. Now you can see here it is 1 plus cos 2 pi tau, 1 plus cos 2 pi tau. So you can see here it is s of, if cos this term become minus 1, so 1 minus 1, that is equal to this term become 0. So it's, so all value of f, for all value of f, the this term s y of f is always getting 0, so it's eliminated, because for f any value of f, this cos become minus 1, this not true. Then of s y of f is equal to 0 for mod f greater than equal to 0. This also not true, because at a particular values, single values, the this function becomes 0, because the cos t has value from minus 1 to 1. So at a particular time, the value of the cos is negative minus 1, and this expression becomes 0, and it's come it's this term comes repeatedly. So but here it is in continuous form, so this option also eliminated. Then Sy of f is 0 for s f equal to n f naught 2 kilohertz, then Sy of f equal to 0 for f 2 n plus 1 or multiple of f naught, where f naught is equal to 1 kilohertz. So let's say, now let's option C. According to option C, it's become now that is f equal to n f naught, where f naught is 2 kilohertz. It means here f become 2 kilohertz, 2 kilohertz or either 4 kilohertz. It means even function, okay, or either 6 kilohertz. So that's why our this expression 2 pi, this expression 2 pi. Now take f equal to 2k, 2 into 10 to the power 3, and t को 0.5 माइनस से प्लस कैंसिल हो गया, 2 से जो पार्ट it's half cancel हो गया, it's become 2 pi, it's become 2 pi. Then it's become, after putting 4k, it's become 4 pi. It means even multiply pi. After putting even multiply this term cos 2n pi, that is equal to plus 1. That's why this term become 1. Then 1 plus 1 become 2. Then this term is non-zero. So option C is also eliminated. Now take now according to this 2n plus 1 is odd multiple of f naught. F naught is equal to 1 kilohertz. Now let's take option D. So now take f equal to f is here, f equal to 2n plus 1 into or odd multiple f naught, where f naught is equal to 1 kilohertz, is become 1 kilohertz, then 3 kilohertz, then 5 kilohertz, and so on. Okay, now put now 2, and here f is now take first 1 kilohertz, so it's become 1 into plus 4 plus 3 into t is equal to 1 by 2 into plus 1 minus प्लस सी से माइनस सी कैंसिल हो गए, ओके, हाफ से यहाँ कैंसिल, बिकम पाई. So after become 2 pi, it's become 3 pi. After become 5 pi, it's become 5 kilohertz, it's become 5 pi. Okay, so you can say if so all value of 5 to 3 pi and 5 pi, this term become minus 1. So 1 plus minus 1, it's become 0. So correct answer of this question is option D. Option D is the our correct option. Now in extend to this question, we extend this question up to this minus. Okay, इस क्वेश्चन को ऐसे वेरी कर दिया. अब चेक करते हैं ऑप्शन को. So you can see here now if you apply del t here, so here it is del t, is become st, here become del t minus capital T, where t is equal to 1 by 2 millisecond, and it is d by dt. Okay, now I am again writing it here, or in the form of Fourier transform. In the form of Fourier transform, it become del t is it's equal to 1. Its Fourier transform is equal to 1. Its Fourier transform it is equal to e to the power minus j 2 pi f t, and its Fourier transform that is equal to h of f, that is equal to, and Fourier transform this term is equal to j 2 pi f, so it become equal to j 2 pi f, then bracket, it's become 1 plus e to the power minus j 2 pi f. Okay, but here it is minus, that's why it's become, this can become minus. Okay, now open this thing, h of I equal to j 2 pi f, bracket, open this term, 1 minus cos 2 pi f t, then sorry, 1 minus cos, and the minus then bracket minus the j sine 2 pi ft. Okay. Now this minus become plus, so it's I'm going to change here. This become plus क्या? Sine. Now taking mod h of that is equal to 2 pi. Yeah. Names become 1 minus cos pi t plus sine 2 pi ft. Okay. It's become pi and whole square, and I am taking as h of whole square. So it become again 1 plus cos square 2 pi f t and minus 2 cos 2 pi t, then plus sin square 2 pi. Okay. So it's become so this term and this term become 1 plus 1, that is equal to 1 plus cos square something plus cos plus sin square, that's something that's become that is equal to this term become 4 pi square f square, and this term, and after taking two common it's become 8. Okay, then bracket 1 minus cos 2 pi. Okay. Now you can see this option and this option is eliminated because the same term will occur. Now by taking option, now taking the option D. Option D, it means that the 2n plus odd multiple of 1 kilohertz. It means 1k, 3k, 5k, 7k. These are the multi frequency. For that frequencies, the s of f is equal to 0. So now take 1 minus cos, that is 2 pi into, let's say f equal to 3 kilohertz. This becomes 3 into or say 1 kilohertz, because odd multiple of this is the odd multiple of 1 kilohertz. So now let's say 1 kilohertz. And t is equal to half, cancel, half cancel, so is equal to 1 minus cos phi. The value of cos phi is equal to minus 1, so that's equal, this value of this equal to minus 1, so it's become 1 minus 1, that is equal to, it's not, so this option D is also eliminated. Now apply the 2k and even multiple of 2k, it means 2k, 4k, 6k, 8k. So f equal to 2k kilowatts or 6 kilowatts. So cos okay, f equal to now 2 kilowatts. T is equal to 1 by 2 into 10 to minus 3 in bracket. So my plus 3 से minus 3 cancel out, half से 2 cancel out, it's become cos pi. You can see cos pi is equal to, it's become it's become cos 2, because 2 is there, so it's become cos 2 pi. Cos 2 pi equal to plus 1. So you can, by the help of this, it's become plus 1, that's why 1 minus plus 1, that is equal to 0. So that's why option C is correct option. C is our correct option. This question was asked in GATE ECE 2015. Zero mean wide Gaussian noise having power spectral density that is n naught by 2 is passed through a LTI system whose impulse response HT, here HT, is shown in figure. The variance of the filter noise at t equal to 4 is. The variance of the filter noise at t equal to 4. It means you have to find sigma y square that is equal to expectation of y square t minus bracket expectation of yt equal to 4. So sigma y square at equal to 4 is become expectation of y square 4 bracket minus bracket expectation of y t4 whole square. As it is given that zero mean. If the input random process has zero mean, after passing through LTI, so the mean of y that is equal to mod h of impulse in frequency domain, the impulse response of that system into mean of x. If this is 0, then this term is also 0, and this is equal to expectation of random process yt. Okay, if either you so at t equal to 4, it's also equal to 0. So that's why this term also 0. Okay, equal to is become expectation of y square 4 at is equal to sigma y square, or you can say it is equal to r y 0, or in other words, it's also say that it is equal to integration minus infinite to plus infinite, integration minus infinite to plus infinite s y of f df. Okay, it can be also written as in term of x, that is equal to integration minus infinite to plus infinite, then the value of this random process, power spectrum density of this random process, that is equal to mod h of f whole square into x of f into df. Here it is given to us that it is the value of s axis of f. It's the value of x axis of f. So now it's become integration minus infinite plus infinite. This become mod whole square into s x of f. Okay, this is equal to n naught by n naught by 2. So n naught by 2 is a constant, it is dx. n naught by 2 is constant, come out from this integration minus infinite to plus infinite mod h of df. Okay, now we know the one relationship, that is perceiver relationship. By the help of this is integration minus infinite to plus infinite mod x t square dt, it's equal to 1 upon 2 pi integration minus infinite to plus infinite mod x of omega whole square d omega, it is equal to integration minus infinite to plus infinite mod x of f whole square df. Okay, d of f. So by the help of these two relationships, so we can see here it is mod h of f whole square df, and it so it's become, so here it's become integration minus infinite to plus infinite mod h of t whole square dt. Okay, Now we have to find. Now we have to take modulus and after square. So that by this term vanishes. This term become like this, and this term become whole square. This become whole square, and the term is like this. Term is like it is, and we have to find the integration of this. It means we have to find the area under this curve, this shape. So it's become triangle whose width is 3 and height is a square. So it's become beta by 2, that is, and height is a square and width is 3. So it's become 3 by 2 a square beta. So the correct answer of this question is option A. Now second. This question was asked in GATE ECE 2012. GATE ECE 2012. The power spectral density of the real process xt for positive frequencies shown below. The values of the expectation of x square and a mod expectation of t are respective. Okay. So it is here. It is the power spectral density of the random process S xt, and it's a positive frequency. It means that there is a replica of negative frequency. It will be framed here. Its replica will be framed here. That is at -10, -9, and it is -11. Okay. Now first we have to find the expectation of xt. Okay, that is equal to limit tau tends to infinite r xx tau. So it's tau tends to infinite means final value theorem. You have to find the value of tau at t equal to infinite. In the frequency domain, it's become limit s f tends to 0. Limit f tends to 0, and it's become s into s x of x axis. Now put here f equal to 0, and it's become s into s x of 0. And so at 0, its value is 0. That's why this value is 0. That's why s into 0 equal to 0. So its mean value is 0 and modulus of mean value is equal to 0. So that's why the mod value is 0. It means this option eliminated and this option is eliminated. Notice 0 and 0. So answer either may be A or B. Now the value of mod xt square. Sorry, mod expectation of s square. It means it is simply become r xx of 0, or you can say integration 1 upon 2 pi minus infinite to plus infinite s xx of omega d omega. Now this limit, now here it is a triangle, this triangular shape, and it is impulse function. It's impulse function. Okay, so it's become 1 upon 2 pi then bracket. So this diagram contains two things. First is that impulse function, and that is this is triangle. This triangle is. So the first we have to find the value of this triangle. That is equal to area of triangle is equal to 1 by 2. Base is 9 minus 11, and it is 10 to the power 3. That is equal to 2 into 10 to the power 3. And height is equal to 6. And plus. I am taking as a integration, that is minus infinite to plus infinite 100 then omega minus 10,000 bracket. Now this 400 is common. It can be come out from this integration. It can be come out from this integration outside. Equal to bracket. Now say how can say this become 6,000 plus 400 बाहर आ गया, and this term become integration minus infinite to plus infinite. And one thing is also I am calculating the area of single here positive frequency, also positive frequency. Okay, but here is also the negative frequencies here. The same shape become framed in the negative frequency. Okay, that's why here we have to multiply it by 2. We have to multiply it by 2. Okay, so integration 10 omega minus 10,000. We have read this property of del function from area under the curve of the del function, that is equal to 1. So this term become 1. So 2 say half ही चला गया, so it's become 406,000 to become 6,400. 6,405. So expectation x square t is equal to 64 by pi. The mean value of this value is 0 and this value is 64 by pi. So the correct answer of this question is option B. Question of the random process. So let xt be the wide sense stationary random process with power spectral density, that is x of f, shown in figure. So ये आपको xt random process की power spectral density दी हुई है, where f is in hertz, आपको frequency hertz में दी हुई है. The random process xt has input applied to ideal low pass filter with frequency response. ये आपको low pass frequency, ये आपको frequency response दे रखा है h of f का. Okay, so it has constant value 1 for minus half to plus half. It means that it has a value, minus half to plus half, and for other than its value 0. And the curve of power spectral density of the random process xt and is passed to the ideal low pass filter. After that, we will get random process yt. Let E be the expectation of the operator. Then consider the following statement. First statement is expectation of xt is equal to expectation of yt. Expectation of x square t is equal to expectation of y square t. Expectation of y square t is equal to 2. Okay. So these are the 4 options. Only one is true. Only first and second are true. Only first and second are true. Only first and third are true. So this question was asked in GATE ECE 2017. So according to first option, expectation of xt, expectation x, okay, that is equal to, we know very well, it is equal to limit tau tends to infinite r x tau x. Okay, you can see it is, we have solved this question so many times. E to the power minus mod f is inverse Fourier transform is equal to 2 upon tau square plus 1. 2 upon tau square plus 1. So it is so you can see it's equal to limit tau tends to infinite. So x tau is equal to 2 upon tau square plus 1. So put tau equal to infinite here, it's become, so this term become infinite plus infinite. It's equal to infinite, and 2 upon infinite is become 0. Okay, now so expectation of xt is equal to 0. Now here it is, now we know very well expectation of yt, that is equal to mod of h of capital F of f0 into expectation of xt. Now you can see here from here if it is range from minus half to half, it means at f equal to 0 you have value h of f equal to 1. It means at h of 0 it's have value 1. So it's equal to h of 0 is equal to its value have 1, and expectation xt it has value 0. That's why 0. So according to first option, expectation xt is equal to expectation of yt, that is equal to 0. Now take the expectation of x square. Now find the value expectation of x square, that is equal to r x x 0, or you can say it is equal to integration minus infinite to plus infinite s x x of f df, that is equal to, now you can see here it is a in function, it is a in function, that's why I am writing here is 0 and from 0 to infinite. The value is e to the power mod x mod f of e to the power minus mod f, it's become e to the power mod f, okay, and df, okay, it's become 2 times of e to the power minus mod f upon minus 1, that's become 0 to infinite, it's become 2 times of bracket, put the f into a 0, that's become 1 minus e to the power, then become minus infinite. So minus infinite becomes 0, so 2, it's become 2 minus 0 is equal to 2. Okay. Expectation of you have to find the value of expectation y square, it is equal to r y by 0. Integration minus infinite to plus infinite, and mod h of it is 1 upon 2 pi, or in term of f, in term of f is 1 upon 2 pi and become h of f whole square and s of f df, and its modulus value is 1, the square value is 1 square, that is also equal to 1, okay, but its limit by the help of this filter, this integration will limit from minus 1 to 1, that will become minus half to plus half, its value is equal to 1 square, and s excess of f, that is equal to e to the power minus f, e to the power minus mod f df, okay, this will become, now you can see it is e to the power mod f, it's in function, that's why I am writing here it is 2 times of integration 0 to half e to the power minus mod f df, that is equal to 2 times of e to the power minus f upon minus 1, limit from 0 to half, so it become 2 times of bracket, that is equal to 1 minus e to the power minus half. After solving this, you will get 0.786. 0.786. So expectation of y square, that is equal to 0.786. This option is eliminated, and this also eliminated. So correct answer of this is the correct statement, only statement 1. So the correct answer of this question is option A. Only 1 is true. So from my side, the random variable and linear process and today. So I have covered all the questions which have been asked in last year in GATE Electronics and Communication Engineering and GATE Electronics and Instrumentation Engineering. Okay, so I'm end my class. Thank you.